Hello everyone, welcome to our case study presentation for the course Industry Practices and Methodology. Before we explore our case study further, let's meet the team. I am Eshita Jain and with me are Aniket, Kumar, Anisha Agarwal and Sakshi Gupta. Each of us bring unique insights which you will uncover as we go along. Now let's dive in. Moving forward, let's look into an exciting overview of our case study scenario in which we have to imagine ourselves at a prestigious medical equipment company right alongside with product and engineering team. In the year ahead, the department is embarking on two crucial missions. First, venturing into health digitalization, enhancing stress test equipment for remote patient data transmission and expert cloud analysis. Simultaneously, developing a user-friendly mobile app for patient data display, record keeping, and health analysis. This initiative aims to empower patient and enhance data management. These are the captivating challenges that lie ahead. To gain a deeper understanding of our case, we will be discussing some questions related to this scenario. Let's kick off our discussion with the first question. The question says, to describe the evolution of domain over the years and how technologies have played a pivotal role in shaping it. The domain of medical equipment and diagnostic has evolved significantly, shaped by the relentless march of technology and the changing landscape of healthcare. We have journeyed from the early days of manual diagnostic tool to the marvel of today's digital age. It all began with stethoscope and basic thermometers, but the game changer was X-ray technology, empowering glimpse inside the human body. Electronics brought automation and precision, giving birth to ECG machine and advanced blood pressure monitors. Telemedicine brought remote consultation and data exchange, while wearables like smartwatches empowered individuals to monitor their health in real time. Then came the era of digital health records, streamlining patient data management. Cloud computing and AI revolutionized data storage, analysis, and diagnostics, enabling more personalized healthcare. The COVID-19 pandemic accelerated remote monitoring and telehealth. Looking ahead, integration of data from various sources is paving the way for a holistic understanding of patient health. In the context of a company's priority, this evaluation highlights the importance of embracing digital technologies for remote health monitoring and analysis, aligning with the industry's direction towards interconnected data-driven solutions. These are the critical developments in evolution in the domain of medical diagnosis.
So moving to the next question, the question says if you want to use machine learning for analyzing the data and coming up with the recommendations to the customer on lifestyle changes based on their health data, current lifestyle, and what has worked for the other like them in the past, what kind of machine learning model you would use, and at a high level, how would it work? What kind of data inputs would be used and what kind of outputs can be expected? To use machine learning for analyzing health data and providing recommendations to the customer, we would typically employ a recommendation system model. It will include data inputs which will be divided into the following categories. The first one would be the patient health data, which will include the patient vital signs such as blood pressure, health rate, and patient medical history, diagnostic test results, and data from the wearables such as smartphones and smartwatches. The next would be the patient lifestyle data, which will covers the current lifestyle habits like diet, exercise, sleep, stress level, and others. The third would be the patient historical data, which will track the past life attempt, success, failure, and the health outcomes of the patient. And finally, we will use the similar patient data, which will compares the health profiles and the lifestyle results from the similar individuals. The machine learning model would be trained on the historical data that includes the patient health and lifestyle profiles, their past life changes, what are the success and failures, and what are the final outcomes of the patient. The model will be based on the two methods. The first one will be the collaborative filtering. It will suggest the strategies that work for the similar individuals with the comparable health data. And second will be the content-based filtering, which will recommend tailored changes based on their unique health profiles. The recommendation system will work in such a way that user will give the input data and the model will provide the customized suggestions, which will include the diet, exercise, and stress management. Then finally the output. The ML model will provide the output. First one will be the user-friendly output. The user will receive these recommendations in an easy understandable format such as a mobile app or a website. For each recommendations, we will provide explanation to help you comprehend how it will benefit you. Then finally the continuous improvement, as the user will follow the recommendation based on the given model output. We will collect the feedback from the individuals, and then this will iteratively help us in refining the system and deliver more effective suggestions over the time. As we progress with our case study, let's address our third question, which says come up with the solution method for the top 3 requirements and elaborate the requirements using mind map. For this, I along with Ishita will walk you through these requirements. Let's explore the first requirement, remote data analysis for stress test machine. To comprehend this requirement fully, we need to understand its goal, priority, and functionality. Then we will dive deep into both the functional and non-functional aspect as well as the UI and UX design. In terms of functional element, we focus on real-time data monitoring, data analysis, anomaly detection, user authentication, API integration, and a user-friendly dashboard. For the UI, we aim for clean and intuitive interface while ensuring easy navigation and efficient access to real-time data for smooth user experience. On the non-functional side, data security, scalability, performance, reliability, and privacy are our key consideration. For the solution method, our goal here is to empower healthcare professionals with real-time remote monitoring and analysis of stress test data. We will achieve this through secure data transmission, real-time processing, anomaly detection, API integration, robust authentication, and a user-friendly dashboard. Now moving to our second requirement, mobile app for patient data access and analysis. Functionally, we break it down into secure user authentication, health data retrieval, health data visualization, personalized recommendations, cross-platform compatibility, and data export features. A user-friendly mobile app interface is crucial for a seamless user experience, and we also consider data privacy, usability, cross-platform compatibility, and performance from a non-functional perspective. Solution method. Our aim here is to empower patients with secure access to their health data and personalized recommendations. We will achieve this through secure authentication, a user-friendly interface, a recommendation engine, cross-platform compatibility, and data export features.
Lastly, our third requirement is integration with smartwatch data. To understand the requirement, let's look into its goal, which is to seamlessly integrate smartwatch data into health ecosystem, enhancing user insights and health monitoring capabilities. Functional requirement use cases includes to tackle data synchronization, compatibility with various data sources, data fusion, real-time alerts, and user-friendly data presentation. The UI focuses on creating visually appealing smartwatch data presentation, while the UX ensures users can easily understand and utilize the integrated data. Non-functionally, we prioritize reliability, data performance, real-time performance, and user feedback incorporation. Here, our solution is to seamlessly integrate smartwatch-generated health data into healthcare ecosystem. We'll achieve this through reliable data synchronization, compatibility with data sources, data fusion algorithm, real-time alerts, and user-friendly data presentation. Our top priority is establishing reliable smartwatch data synchronization. These all requirements form the core of our case study, and by exploring their solutions and intricacies, we'll gain a deeper understanding of the challenges.
Let's move on to the next question that we would like to discuss. The question says to use the 5-step project management plan to create a plan for the product within the given scope. Step 1 is to define the goals and constraints. Moving on to step number 2, that is dependencies. To successfully achieve our goal, we recognize that there are numerous dependencies to manage. These dependencies range from technical to resource dependency. The technical dependencies include integration of the stress test machines with the cloud platform, as well as the smartwatch data with the cloud platform. Development of machine learning models is required for data analysis, and mobile app development should include secure login and data visualization. As it is important for any organization, we have to set up the cloud infrastructure as well as the security configurations. In terms of resource dependencies, a very important dependency is the availability of skilled developers and data scientists, as these will lead the project management. Another is the collaboration with smartwatch companies and accept their data sharing protocols. We also need to have compliance experts so that we ensure that we are adhering to the regulations as provided by the organizations. We also have cloud service providers and their support for healthcare compliance, as these will be helping us in terms of our cloud platform. Managing dependencies also means that we anticipate potential bottlenecks and have contingency plans in place. For example, if a regulatory approval takes longer than expected, then we need a plan for how this might impact the overall timeline and how we are supposed to mitigate any delay. Moving on to step number 3, assumptions. Product management in any organization moves forward with certain assumptions. In our case, it is regulatory approvals, where we assume that all the necessary regulatory approvals for healthcare data handling will be obtained in a timely manner. We also assume that data volume will remain within expected limits and we won't significantly exceed our initial estimates. Also, we assume that partnerships with smartwatch companies can be established according to the timeline. And lastly, technical feasibility, where we assume that the required technical integrations and developments are actually feasible within the given time frame. Now, while we make educated assumptions based on market research and industry trends, we need to understand that these assumptions may not always align perfectly with reality. Moving on to step number 4, that is risks and mitigations. A critical aspect of any project management strategy is identifying and mitigating risks. In our case, the risks can include regulatory delays, as discussed before, which can be mitigated by engaging regulatory experts and submitting applications as early as possible to expedite approvals. Since we are dealing with a lot of healthcare data as well as patient information, there can be data security breaches for which we need to implement robust encryption, access controls, and monitoring systems. We also need to conduct regular security audits. Technical challenges may include unexpected technical issues that may arise during integration, development, or deployment. The mitigation for this is to allocate extra time for contingency planning and addressing these technical challenges. We also have risks in terms of partner dependencies, which means that there might be delays or complications in establishing partnerships with smartwatch companies due to market trends or due to market issues. We can mitigate this by identifying backup partnerships and maintaining open communication with potential smartwatch partners. Moving on to the final step, that is mobilization plan phases. What is a mobilization plan actually? A mobilization plan means a strategic document that outlines the steps, resources, and activities required to prepare for and launch a project or initiative successfully. The way I see it, it ensures that all necessary resources are in place and ready for action when the project begins. In our case, the first phase is planning. The planning phase ensures that we have a solid roadmap to guide us through the project. During this phase, we focus on defining project objectives, scope, and requirements. We identify key stakeholders, assemble the project team, and assign roles and responsibilities. We also set a clear project timeline, set up the budget, etc. Phase 2 is development. This is where the actual work begins, including designing and building the product. An important thing is collaboration and communication, which is very vital in this phase to ensure that the development progresses smoothly. Phase 3 is testing and quality assurance. Quality is paramount in any mobilization plan, and due to this, testing and quality assurance phase is where we ensure that the product meets high standards. It involves rigorous testing, both functional and non-functional, and it is conducted to identify any issues and also rectify them. Phase 4 is deployment. Deployment is the final phase of our mobilization plan. Here, we prepare to launch the product or solution to the intended users or customers. We also ensure that we have necessary infrastructure and support systems backing up our product. Additionally, we can also supply user training and documentation so that the users can easily use that product. And then finally, a rollout plan for our product is executed.
Now, we would like to take the next question, what we'll be using for testing our mobile application, and give 5 to 10 key scenarios that we would be testing for. Also, we will discuss what we can do to keep the Android and iOS app release in sync, and what are some of the best practices that companies currently use for this. Testing a mobile app thoroughly is crucial to ensure it functions flawlessly, provides a great user experience, and complies with healthcare regulations. To test the app effectively, we can use a combination of manual testing and automated testing tools. These are different testing scenarios for our use case. User authentication. We need to verify user registration, login, and password reset features to ensure secure access to health data. Next is data visualization. We need to ensure health data, graphs, charts are entered accurately and responsively on various devices for clear user understanding. Next is data sync. To test the seamless integration of medical equipment and smartwatches with the application, and to validate data accuracy and consistency. Next one is medical reminders. We need to verify medication reminders are triggered correctly and include zooms, dismiss, and tracking options. The next one is health recommendations. To test the personalized health recommendations based on user data, align them with the user's health profile. Next is secure messaging. To test the secure messaging between patients and healthcare providers, ensuring message delivery and attachment support. Few more are emergency response. This is a crucial one to test. We need to ensure emergency features like contacting emergency services work correctly even in offline. Coming to the application testing, the following process needs to be followed. First is test planning. Test planning involves determining what needs to be tested, how it will be tested, and who will be responsible for testing. Next step is requirement testing. Requirement testing involves evaluating the software against the documented requirements to ensure that it meets the specified criteria. This testing phase ensures that the software aligns with the intended functionality, user expectations, and regulatory requirements. The next step is functional and non-functional testing. Functional testing assesses the software behavior and functionality by testing specific features and user interaction. Non-functional testing focuses on aspects like performance, security, usability, and scalability. The next step is regression testing. Regression testing is conducted to ensure that new code changes or updates do not introduce new defects or break existing functionality. The final step is reporting. Reporting in testing involves documenting the testing process and its outcome. Next, we would be discussing what we can do to keep the Android and iOS app release in sync. To keep the Android and iOS app release in sync, it is essential to adopt cross-platform development frameworks like Flutter or React Native. These frameworks will allow us to maintain a single code base for both the platform, streamlining development, testing, and maintenance effort. Continuous integration and automated testing tools ensure consistent test coverage across both Android and iOS. Best practices include version control, parallel development, code reviews, shared design system, and comprehensive documentation. Each step is crucial to minimize disparities between platform-specific code base, ensures feature consistency, and deliver a synchronized high-quality app experience to ensure on both Android and iOS platforms. Importantly, this approach reduces development time and resources while enhancing the overall quality and user satisfaction of the mobile app. These are few of the best practices that companies currently use for cross-platform application development. They implement a shared design system to ensure consistent UI UX, use feature flags to control feature availability on both the platforms, they conduct joint sprint planning and retrospectives, maintain comprehensive documentation for both Android and iOS code base, encourage collaboration and knowledge sharing between platform-specific teams. By adopting these practices, companies streamline cross-platform application development, maintain feature consistency, and ensure a synchronized release process for Android and iOS apps. Now, we would like to thank you for providing this wonderful opportunity, and it was a great learning experience doing this case study.